Many of us have had to take some sort of science class in high school in which they taught us about space. But if you're like me, you thought it was interesting on the surface, but never really cared to dive deeper into anything you were learning. It wasn't until my father shared with me his fascination with space that I ever thought about looking things up. He has had large, astrology books in our living room for a very long time, and one day I decided to crack them open, and then he has been obsessed with trying to teach me about space ever since. So, I decided that for my last speech, I will be talking about black holes. I will be discussing what a black hole is, how black holes are formed, and why they are important. First, what is a black hole? According to NASA, a black hole is a point in space where there is a great amount of matter packed into a small area. There are three kinds of black holes, the first of which is a stellar black hole. When a star burns through the last of its fuel, the object may collapse or fall into itself. For smaller stars, those up to about 3 times the sun's mass, the new core will become a neutron star or a white dwarf. But when a large star collapses, it continues to compress and creates a stellar black hole. Black holes are formed by the collapse of individual stars that are relatively small, but incredibly dense. According to the Harvard-Smithsonian Center for Astrophysics, the Milky Way contains a few 100 million stellar black holes. The next type of black hole is the supermassive black hole, which we've all heard that song. These enormous black holes are millions or even billion times as massive as the sun, but about the same size in diameter. So, mass. Such black holes are thought to lie at the center of pretty much every galaxy, including the Milky Way. Scientists aren't sure how such large black holes spawn, actually. Once these giants have formed, they gather mass from dust and gas around them, material that is plentiful in the center of the galaxy, and allowing them to even grow to a more enormous size. Supermassive black holes may be the result of hundreds of thousands of tiny black holes that merge together. The third and last type of black hole falls somewhere in the middle, which is why it's called an intermediate black hole. An article published by Space.com in July 2019 states, scientists once thought that black holes came in only small and large sizes, but recent research has revealed that the possibility that mid-size or intermediate black holes could exist. Such bodies could form when stars cluster or collide in a chain reaction. Several of these intermediate black holes forming in the same region could then eventually fall together in the center of the galaxy and create a supermassive black hole. Aside from the different kinds of black holes that exist, let's talk about the way black holes are formed. The most well-understood black holes are created when a massive star reaches the end of its life and implodes, so it collapses in on itself. Black holes have 3 layers: the outer and inner event horizon, and the singularity. The event horizon of a black hole is the boundary around the mouth of the black hole, past which light cannot escape. Once the particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. The inner region of the black hole, where the object's mass lies, is known as its singularity, the single point in space-time where the mass of the black hole is concentrated, so in the middle of the black hole. Scientists can't see black holes the way they see stars and other objects in space. Instead, astronomers must rely on detecting the radiation black holes emit as dust and gas are drawn into the dense creatures. But supermassive black holes, lying in the center of the galaxy, may become shrouded by thick dust and gas around them, which can block the emissions. Lastly, what is so interesting about a black hole? Well, maybe you haven't thought about it, but I'm sure many of us have. What happens if you were to fall into a black hole? I found an article on BBC Earth that was published in 2015 that explains pretty much exactly what were to happen. The author of the article, Amanda Gefter, I think has a great hypothetical about if we were to fall into a large, so a supermassive black hole. She says, let's start by asking your space companion, we'll call her Anne, who watches in horror as you plunge toward the black hole, while she remains safely outside. From where she's floating, things are about to get weird. As you accelerate towards the event horizon, which is, remember, the outer mouth, the top, which is what you normally see in pictures, Anne sees you stretch and contort, as if she were viewing you through a giant magnifying glass. What's more, closer you get to the horizon, the more you appear to move in slow motion. You can't shout to her, because there's no air in space, but you might try to flash her like a Morse message with the light on your iPhone. However, the words, flashes, reach her ever more slowly. The light waves stretch increasingly, and they lower and redder, like the frequency. When you reach the horizon, Anne sees you freeze, like someone has hit the pause button. You remain plastered there, motionless, stretched against the surface of the horizon as the growing heat, because they're very hot, begins to engulf you. According to Anne, you are slowly obliterated by the stretching of space, the stopping of time, and the fires of Hawking radiation. Before you ever come across the black hole's darkness, you're reduced to ash. But, she says, before we plan your funeral, let's forget about Anne and view this from your point of view as you're falling into this black hole. Now something even stranger happens. Nothing. You sail straight into the nature's most ominous destination without so much as a bump or a jiggle. That's because you're in free fall and you feel no gravity, something Einstein called his happiest thought. If the black hole were smaller, you would have a problem. The force of gravity would be much stronger. But you could live out your life pretty normally before dying at the singularity. Sorry guys, I'm running out of time. But that is my overview on black holes and the mystery that surrounds them. Thank you very much. Sorry guys.